All right, so I'm here to tell you a little bit this morning about natural language understanding and how it fits with modern machine learning, and how we can use that to more deeply understand what people are saying in documents. And this goes beyond just sentiment analysis and things like that to really get into the meat of what people are saying, the topics they're talking about, and what's really driving ROI. And on the way, I'm going to tell you a little bit about a kind of artificial intelligence that you probably haven't heard of, at least haven't heard of for a really long time. It goes by the name of common sense reasoning, which is about taking, thank you, yes, and talk about how it's moved into the modern era and what we're doing with that now, because yes, I'm from that particular part of machine learning. And we'll talk a little bit about that and show you how it really matters to your KPIs and to the things that matter to your business. All right, so to give you a little bit of background on Luminoso, if you haven't had a chance to stop by yet, and I think the booth is over, so I'll tell you all now. Luminoso is an unstructured analytics company. We help Fortune 1000 companies and other folks make sense of their unstructured data, especially customer feedback. So if it came from a person, intended to be read by a person, and you have too much of it, and you wish the computer was reading it for you and doing what you want people to be doing, that's what we do. And we do it in many different languages without translation, because translation loses a lot of the nuance that you have in there, including the hard languages, Japanese, Chinese, Arabic, Korean, all those things. So I would also love to talk to you if you're interested in computational linguistics as well later, although I'm not going to be talking about that now. And we really focus on helping people find the unknown unknowns. So the things that are hiding out in your data that you don't know about, the things that people don't want to admit in structured polls, all of that kind of information, and try to see if we can figure it out and add it back in to your business processes. And we do that using modern machine learning, which you guys have been hearing a lot about. But we don't require an enormous amount of training data. I'll tell you why in a second, and that's the common sense. And it doesn't require a lot of manual intervention, consultants, all that kind of information. And that means it specializes to domains pretty quickly. So that's what I'm going to tell you about Luminoso, and then I'm going to get into a little bit more about why you can use this kind of information to sort of make a business difference. So the quest to really understand natural language at a deeper level is not something new. It's not something that has come about when people started talking about deep learning or intelligent agents or in-home robotics or the Internet of Things. It's something we've been trying to do for a really, really, really long time. And that's because there's so much under the surface in what an individual says and what a person says, and being able to grab that knowledge, pull it out, and really quantify it, and tie it to your other kinds of information, put it into your predictive analytics systems. This becomes incredibly important. And there's this feeling that to be able to really do natural language understanding right, there are sort of two camps. There's the feeling that this is impossible, that we'll never be able to make a dent in this, that you have to build these huge ontologies, these huge rule-based systems, to be able to really tackle the nuances of what people are saying. On the flip side of that, you might, if you're trying to convince somebody that you need to invest in natural language understanding, you might run into people who are like, isn't this problem solved? I can talk to Siri. I mean, and so the truth of the matter is that we're in neither place right now. The truth of the matter is that, we really have been making a lot of strides in being able to understand natural language. I think there was a speaker earlier this morning that was talking a little bit about that. But we do have a bunch of challenges in being able to use what's called distributional semantics or deep learning to really get under the hood. And we'll talk a little bit about how common sense solves that. I think the key problem is that language is really difficult to understand. Because when people are passionate about something, whether it be politics or whether it be why their phone is exploding, people really use creative language to talk about that. We are very excited. We love to use hyperbole. We love to use slang. We love to really chew people out when we get upset in customer service, and that becomes a real big problem. Because although you and I are very good at creative language, if the computer hasn't seen it before, it becomes very hard to understand that. There's a piece of linguistic philosophy, actually, that you can really take a look at that says basically we are basically evolved to try to be conversationally interesting, to use things that are interesting phrases, to make witty jokes, to do things like that, because we feel like when we do talk like this, we're much more likely to be understood. So if you're reaching out to a customer service agent or something like that, your head is telling you, be creative, be funny, use slang, use metaphor, use hyperbole, figure all these things out. And that makes it really hard for a computer and much more easy for a person to understand these things. So that's traditionally been a big problem. And I think the industry started out looking at sentiment analysis as really the first way of doing this, because you can get easy wins in sentiment analysis. There's a lot of places you can go, or you can say, yes, this is positive, yes, this is negative. There are hilarious things that went wrong in the early days of sentiment analysis, but you got a good deal of the way there without a lot of effort. And that became really important because it became something that people could believe in natural language understanding again. But I think the real key is that if you only look at sentiment, you're really missing a lot of what's going on. Because the questions you need to answer for your business are a lot more complex than that. And one of the things that's important to note is if you think about these questions that you have, you can easily sort of push against that. Questions like the question we have on the screen right now, those things you can answer by positive or negative. They're a lot more complex, they're a lot more meaty, and those are the questions that, in my experience, have really tended to be the questions that drive ROI and really drive your business objectives. So recently, it really looks like deep learning is the answer to a lot of things, and that's not just in language, it's also throughout a lot of machine learning. And I think there's a lot of things that have moved forward in artificial intelligence that are really interesting. Traditionally, we've looked at all these keyword lists, these ontologies, they're very labor intensive, things like that, and the promise of just saying, hey, we read the whole web and now we can figure out anything is really important. But it's really brought that kind of stuff from something that takes months or years to something that takes minutes or weeks, right? And that's really very exciting. It also brings the bias out of the equation. As an earlier speaker had said, when you go in and you build these rules and ontologies, you bring all your own bias in, and you're unlikely to find stuff that doesn't match what you thought was there in the first place. But there's something missing from that as well, which is sort of the stuff under the hood in the way people talk about the world, what's going on between the lines. It's a bit early for crowd participation, so I'm not going to do that to you. But if I said I went to the grocery store, there's a whole lot of things you need to understand that. You need to understand that you probably, if you're not in San Francisco, you probably drove there in a car, you probably bought your groceries, you put them in the trunk, you exchanged money for goods and services, as they say on The Simpsons. You took all this stuff and you bought it, and you're probably not eating it in the grocery store. And we bring all of that baggage to a sentence that we understand. And that's the stuff we use to really understand the creative language. But if you go out there and you look around, you're never going to find any of that, because we don't say it, because going back to what I said earlier about linguistic philosophy and trying to be interesting, if we say these things, we're really boring, so nobody wants to hear you talk about the fact that you paid for groceries with money in the grocery store. So we need to bring some of that to the table. Traditionally, this has been a field called common sense reasoning, which has also traditionally been one of those fields that's full of things like ontologies and rule-based systems and all that kind of stuff. And I'm going to talk a little bit today about what that means in the world of knowledge graphs and machine learning, and how we can bring that to something like distributional semantics to make it a lot better. And really be able to illuminate the unknowns, because once you know what you're doing at the grocery store, it becomes a lot easier to understand that analogy or understand that piece of feedback. And I think one of the big reasons that happens is because there's a lot of domain-specific data. If you think about AlphaGo, and you think about those systems, you realize that to train something like AlphaGo, it took 30 million Go moves. And then they ran out of Go games because there weren't enough digital Go games, so they had the system play itself. You can't have your contact center call itself. And so there's a problem here, which is that the huge machine learning that's been getting all the advances, it doesn't scale down to the enterprise. It's all web scale. And if we want to say, even if you're a big company, if you want to take this data, move it down and say, look, this is the quantity of data we have, how far can we get? You're going to need to bring something else to the table. And that's not just the only problem. The other problem is that synonyms and things like that are discovered by this kind of traditional, distributional semantics-based machine learning are not necessarily what you want. And what it's finding is essentially things that can swap in and out for each other in sentences. And that's not always the right thing. For example, high school spelled wrong is much more a better match for high school than elementary school. They don't have the same meaning. They don't have the same things. I'm from Boston. You can't really swap the Red Sox in for the Yankees and still get the same meaning. That doesn't actually work. So we need to be able to look a little bit deeper. And so how people do this kind of stuff is that we know a lot of things, and we know that other people around us know those things as well. And so we kind of bring those assumptions to the table. And when we're talking, we assume the person we're talking to knows these things, and they're called common sense. So in addition to running Luminoso, I started a project called the Open Mind Common Sense Project, or CONCEPTUAL, in the late 90s, back when we were trying to help Alta Vista and Hotbot make search smarter. because people were talking to their search engine a lot how people talk to Siri now. Anybody remember that? Like people would tell their search engine, my cat is sick and things like that. Do you remember that? And it didn't work so well. So at the time, we thought the right thing to do would be to find everything that people know and computers don't and give it back to search engines, and that would solve all the problems. Now, some folks out at Stanford had a better idea on how to solve some of the problems with search. We won't talk about that. But what we ended up doing is starting out what would become one of the first crowdsourced projects, where we basically took all the knowledge that people had. Originally, people would just give us stuff, because back in the 90s, if you were doing crowdsourcing, you didn't have to pay people. It was a little nice. And then we did games with a purpose, and then we did linked data, and that's a whole nother talk. And so then we took all this information in to build a very big knowledge graph. And essentially what's going on is that this pertains to the theory that you understand concepts and connections by their connections to other words. So if you want to buy groceries, we know it requires money, and money is in your wallet and things like that. And if you keep going on this, you'll eventually build this giant knowledge graph. So this is like the Google knowledge graph, only it doesn't know anything about Hillary Clinton. It doesn't know anything about Barack Obama. It doesn't know anything about your named entities and your temporally relevant stuff. It's just about the things that make the world tick. And that's what ConceptNet is, basically. It's this big knowledge graph about the world. But if you think about it, you're going to run into a problem pretty shortly. And I'll get into that problem in a second. So we did this in English, and then we teamed up with, every time I'd give a talk somewhere, I'd say at the end, if you want to build these one of your languages, come find me, and people would come find me. And so we started building them in partnering with other universities, other companies, and we built them in many, many different languages, and then we started learning how to build them automatically. And so eventually it became very global. And we collected a whole ton of facts about the world. And that allows us, and the design of this was to say, let's take this big knowledge graph, let's put it into machine learning, and let's connect those dots that aren't easily connected by distributional semantics. Except we didn't know those words at the time, so it all works out. And this effort has been going on since the late 90s. I think one of the things that's really interesting here is that this really helps us understand complicated concepts. Now, if you think about it, why is coffee bean in a mug one of those things that helps you understand anything to do with customer service at all, right? So the idea is that we understand complicated concepts and complicated domains in part by making analogies to simpler domains. So it becomes much easier for us to understand stuff. And this is all a process that happens without us thinking about it very instantaneously, all that kind of stuff. So information, if you think about the way we talk about information, we talk about it the way we talk about water. And so if we know a lot about water, maybe we can make some good guesses about information. And that's another piece of linguistic philosophy. But the basic idea here is you're going to need to scale that up a lot, because if you're grabbing all this data from the web and you're building this big knowledge graph, you can never build every connection you're going to need. If I asked you, would a giraffe be happy in this room? Every one of you has an answer right now. But none of you thought about this problem ever before, or at least I'm guessing you didn't think about this problem ever before. And that's really something that's important, because not only are we collecting and knowing this knowledge, we have to be able to add it into our reasoning processes. And that's essentially a digital intuition here. And so what we want to be able to do is combine those things together. You want to be able to use this giant knowledge graph, combine it together with the kind of machine learning we're seeing in something like Word2Vec or other types of deep learning and distributional semantics, be able to use those things together to more quickly learn domains, and it works. So what you're doing is you take your model from a deep learning system, you add in the common sense, and you add in the domain information. The common sense lets you learn the domain information. You learn it from very few data points, and then poof, you have a model for your domain that didn't take millions of training examples, that didn't take you learning web scale data, and that didn't really take you being able to have to spend a lot of time and a lot of consultant work to be able to do it. So you're combining together the best of both worlds. It's sort of the compromise. And I think that's, and our evaluation metrics and things that are coming out in the next couple of months really show us that gets you quite a bit further towards things like analogy and similarity, and the other things that have really been hallmarks of saying, hey, how does natural language understanding work? So how does this kind of machine learning work in the wild? What can you expect from it? Let's get back to business and a little bit more from the sort of AI philosophy that was going on here. So we were working with a large Japanese car manufacturer, and they have this great old taxonomy about different things that can go wrong with different models of cars. And dealers will write in reports, and they'll get stuck in the right box, right? And like everybody else, they have this bucket that says other. And you probably have a bucket that says other, and everything that falls into the bucket that says other never sees the light of day, right? And so one of the things is, let's take everything that's in the other bucket and let's figure out automatically whether or not there's some interesting clusters, interesting continuums, things that you can see in there. And there were a whole lot of people talking about the fact that their car smelled in different ways. So some people were saying, well, it smells like the dog was in the car, but my dog hasn't been in the car. I don't even have a dog. It smells like an attic. They were using really interesting language. It smells funky. You know, people talk about cars. They talk about the knocking sounds. You also talk about the same kind of thing with the smell. And that was really odd. And on the flip side of that, there were a bunch of people who were talking about dew. Like if they got in the car, there was dew on the inside of the car as well as the outside of the car, and that was very odd. Computer can make the connections between those two things. Amongst other things, it can know that all these people talking about attics and dogs and musty odors and things like that are all probably talking about the same thing. You never would have coded that in because you never would have thought a car would smell musty because you never would have thought you would have a mold problem in a car. You combine it together with the dew on the inside of the car automatically, and then you end up in a completely automated way discovering that what was happening was, well, mostly automated. The air conditioning hose in this model of car was coming undone, and water was getting in the car, it was getting the car musty, and then people were driving into their dealerships and saying, my car smelled bad, and then the dealers were saying, you're nuts to the people who own the cars, and that was not helping with customer NPS scores here. You know, if you come in and you say, my car smells terrible, and the dealership's like, no, that doesn't help your image. And so it really was important for them to be able to go out to the dealership and show that. And of course, there are more traditional stories like this with carburetors and with knocking sounds and with automatic steering and things like that. But I think this really highlights the idea that if we take the stuff that we know in our heads, add it back into systems, we can make conclusions that really drive business value. Another favorite example I'll do fairly quickly because I want to get to the third one is near our office there's a Thai restaurant. In Cambridge, Massachusetts. There was a Thai restaurant for many years. I think it's now turned into Novartis, like much of Cambridge. And if you went there and you ordered Thai food, it was not very good. But if you looked on Yelp, the reviews were very mixed. And so that was very interesting. Maybe some people don't like very good Thai food. So you want to figure out what's going on. You take all the reviews, you put it into the system, and you discover very quickly that there's a correlation between people who are happy and people who like spicy food. And that's weird. And so if you dig a little bit deeper, and you don't really need to dig that deep to find that, you find out that there is a secret Szechuan menu, and that this is not a Thai restaurant run by people who are Thai, it's a Thai restaurant run by people who are Szechuan, who have a secret menu you can order off of that's delicious, and the Thai food's not very good. So if you would never have brought this assumption to the table if you were taking to a place with a name like, you know, Thailand Cafe, and being able to understand a little bit more about how people react, how people talk about food, that kind of stuff will get you that particular insight. Lastly, in the world of market research, if you are working with a company that does men's toiletry products, if you ask a guy whether or not the color of his toiletry product matters at all and how he buys, he will tell you no in every numeric survey that you ever do. And this is a tremendous problem for companies out there like, you know, the CPG companies that are out there. And yeah, everyone suspected that that's not actually what was going on, that there is correlation. So they went and put 3 more brightly colored prototypes, some of them were brightly colored, some of them weren't, in the homes of consumers for about 2 weeks, called them on the telephone and said, tell me about your experience with this product. And so if you do that, you find that people talk in a way that indicates that they're more devoted and more energetic about the product for more colorful products than products that aren't. And also, if you don't ask directly about color, some people will talk about it. If you ask about it, fewer people will talk about it. And you can make that correlation. And you can say, look, if we go out there and we make a more brightly colored product, it will sell more. And in fact, it did. It became their most best-selling SKU in that line. And so essentially, I've given a lot of more on the marketing or market research on case studies, but you can see how you can bring this kind of thing and this kind of sort of common sense back into something like an intelligent agent to do something like intent recognition. You can work in customer service, which is a whole lot of what we do right now, being able to understand what's coming in and all that kind of information. And it's really important to really sort of use this common sense to get underneath the hood. And in the end, you know, that's what it comes from. That's what it comes down to. It comes down to, can you really understand people's motivations and goals in ways that are not apparent from the words that they use. So I want to thank you guys this morning and take a few questions. Yes, very excited guy.
I have a question. When you talked about combining ML with concept system and building domain knowledge, could you elaborate that a little more?
So I think there's been a lot of really interesting work recently, of which our company does part of this, in being able to take something like a knowledge graph and use it to perturb the kind of machine learning that's being used in something like deep learning. So to give a higher level answer, what this means is to say, if you get a model of how the world works, you want to be able to augment that model with things that everybody knows. At a more technical level, what you're doing is you're taking your space. So what these models do is they build this big space about the world that looks kind of like a big constellation of word meanings. And you can move the stars in the constellation around based on things you know for the domain, based on things you know for common sense in different ways. And that's really what we're doing. And if you want to get more technical, I'd be very happy to talk to you afterwards or at the coffee break. Yes?
Just to slightly extend that question a little
Yep.
further. So you mean like an ontology that describes the domain?
It could be an ontology that describes the domain. What we do at Luminoso is we use a big knowledge graph of common sense. I think knowledge graphs are better than ontologies for this, because in a knowledge graph, you are multiply connected in a bunch of different ways. So,
If you throw data together with the ontology, then you get a knowledge graph.
well, you make everything vectors first and then you do it, but yes. And I think the answer is that basically one of the reasons why initially words as vectors and deep learning and that kind of stuff didn't take off is because if you put an ontology in, you don't get the same kind of results you do if you put a knowledge graph in, simply because an ontology isn't connected as fully connected as something like a knowledge graph. And the messier and more connected things are, the better your machine learning gets.
So the knowledge graph becomes input to your machine learning training system.
Afterwards. You do it afterwards. I can explain more after the fact. And that's important also, because if you're running one of these big systems, you need to run them on GPUs and you need to run them with lots of data. But if you want to customize to a domain, you want to be able to do it very quickly in minutes. You want to be able to do it on device. Then you don't want to go back all the way to the beginning and run the whole machine learning over again. You want to say, let's take what came out of it and modify it, which is what we do. Yeah. Mm-hmm. Yep.
Thank you for a great talk.
Thank you.
I'm wondering, talk about distributional semantics.
Yeah.
Into meaning. Have you guys looked at how you could do actual logical reasoning by combining knowledge graphs?
I think that's one of those things that's really interesting question. I mean, I think right now there is a lot of very, very causal types of stuff that you would see in something like log reasoning, that kind of stuff that you're talking about, that we really haven't figured out a great way to deal with. There's been a lot of interest in taking this kind of stuff and combining it with that kind of stuff. The field I come from in common sense does a lot of that logical reasoning as well. And there's been a movement for probably about 10 years to bridge the gap between the two. But I think it's really been a question of finding somebody with a business problem that needs it to happen in the end.
Can you talk about a use case in healthcare?
Sure. So I think my favorite use case in healthcare was looking at patient journey information. Right off the bat, one of the things that happens, this is more an anecdote than a use case. One of the things that happens is that people use a lot of slang, they use a lot of different words, and they misspell a lot when they talk about drugs. So you really need to be able to use that sort of analogy-based reasoning that I was talking about to say, look, these two things are likely to be the same thing. And in the flip side of that, that means you can go out on the web, you can see how patients are talking about different diseases, and you can say, can we understand a little bit more what the emotional journey of the patient is through this to help doctors be able to talk to patients a little bit more to increase adherence. I would love to talk more about healthcare later. Yeah. Anybody got anything else? Okay.
You had a lot of customer relations studies.
Yes. Yeah.
Planning for the flip side of that.
I don't think planning, we haven't really done a whole lot of planning ourselves. I mean, I think it's something that's an interesting application. We have a very broad platform, but one of the things you do is you focus. You find a focus that works for your business. So we have an API, and we have a lot of folks who use the API to do things that are like ad targeting and predictive analytics and all that kind of stuff that aren't core to what we do. And we help you do that, but we don't do it ourselves. All right. Thank you.